Hello students, I welcome you all in the quick solutions of All India AIATS test series Medical 2019, and I am here with the chemistry part of test number 1, code A and B. So let us begin with the very first question, and that's the question number 46. As per this question, the number of carbon atoms present at lattice points and voids per unit cell of diamond respectively. So what thing that you should focus here? That we have the crystal of diamond and we just have to consider what type of crystal it is. So simply we should know that we talk about diamond, it has FCC lattice. And if it has the FCC lattice, what we have to point here, we have to just find out the number of the carbon atoms present at the lattice point as well as at the voids. So simply if we talk about diamond atom, there are the carbon atoms present at corners simply and face centers, as well as these are present at alternate tetrahedral voids. Now as we know that these are present at 3 positions, so we just have to find out. First we'll see that at the lattice point how many carbon atoms are present. So there would be 8 into 1 by 8, because one atom is shared by the 8 unit cell, that's why we are taking this. And at the face center 6 into 1 by 2, and if you calculate it you will get 4. And further at tetrahedral voids, if we want to find out the number of carbon atom, these would be total 8 into 1 by 2. Half of the tetrahedral voids, basically alternate tetrahedral voids, are occupied by carbon atom. So simply it would also be 4. So if we have these two numbers, it means 4 at the lattice point and 4 in the voids. So it means the answer that's correct here is the option 1. So I'll write here the correct answer, that's option 1. So let me mark it here, the correct answer. Now let's move on to the next question. So here we have the question number 47. For an aqueous solution of K4FeCN6 strong electrolyte, the Van 't Hoff factor I will be. Simply in this question we have that K4FeCN6, it's a strong electrolyte. This is the fact that's given here, and we have to just calculate the Van 't Hoff factor. For this we just have to see how this complex compound or the coordination compound get dissociated. In the aqueous solution it gets dissociated to form 2 type of ions. One is the potassium ion, the number is 4, and one complex ion would be formed here, FeCN6. This is a complex anion that would be formed here. Now as you calculate the total number of the ions produced here, those are 5, and if it is 5 for the strong electrolyte, then Van 't Hoff factor I would also be 5. So what is the answer here? The answer is option 4. So the answer that I should mark here is option 4. Now let's take the next question. We have the question number 48, which among the following is the best conductor of electricity. We have the 4 different solutions, all of them having the same molar concentration. If you check here, the first one is 0.1 molar aqueous ammonium hydroxide, the second is 0.1 molar aqueous urea, third is 0.1 molar aqueous acetic acid, and the fourth one is 0.1 molar aqueous NaCl or the sodium chloride. So simply in this case all are having the same molar concentration, but the electrical conduction depends on the number of ions produced, and we know that the strong electrolyte produce more number of ions. So simply here we have the strong electrolyte, that is sodium chloride. So when we look at 0.1 molar NaCl, it's a strong electrolyte. And it will produce the maximum number of ions. And hence it is the best electrical conductor. And otherwise, if we check about the first option, that is NH4OH, weak electrolyte it is. The third option, acetic acid, that's also the weak electrolyte. And if we talk about the urea is non-ionic compound, it will not produce ions, so simply it is not a conductor. And ultimately the correct answer for this particular question is, you can easily mark, this is option 4. That's our answer also. So mark here, this is the correct answer. Now after this, let's move on to the next question also. We have the next question, that is question number 49, and it says the slope of the line plotted between L and K versus 1 by T for Arrhenius equation is given by. Simply in this question you just have to consider the Arrhenius equation. That Arrhenius equation is K is equals to A, that is Arrhenius constant, and the exponential form is there, e raised to the power minus EA by RT. This is your Arrhenius equation. By taking log, it becomes ln K, that's equal to ln A plus minus EA by R, and outside the bracket I am writing here 1 by T. This is EA by RT. Now here if you compare this equation with y is mx plus c, what is that? That is equation of a straight line mx plus c. Then you can easily identify that you are plotting 1 by T at x-axis, at y-axis you are taking ln K, then the slope will definitely be minus EA by RT. So the slope is minus EA by R. Then which option is correct? You can easily identify the correct answer. That answer is given in option 2. So I'll mark here the correct answer. The answer 2. Now after this, let's move on to the next question. We have the next question that's given here, the question number 50. Smoke is a colloidal solution of. So quite easy question. It's based on surface chemistry, the colloidal solutions. And the first option, solid in solid. Second is solid in gas. Gas in gas is the third option. And gas in solid is the fourth option. Simply in this question, you just have to consider that smoke is given. And we know that the smoke is created by the carbon particles which are suspended in air. Basically in this particular question we have the solid that is suspended in gas. So this way the correct answer for this question is option 2. So I'll write here the correct answer, that is option 2. Now, after this, let's move on to the next question. Now here we have the question number 51. Select the correct statement regarding enzyme catalysis. It means ये question based है enzyme catalysis पे. And if we talk about enzymes, these are biocatalysts. And these biocatalysts are basically proteinous in nature, and these are the compounds with high molecular masses. Further, if we talk about the enzymes, these enzymes are very much reactive at the optimum temperature and optimum pH. Now, let's check the options given here, in which the statements you have to check, and just you have to find out the correct statement. First option हमारे पास है enzymes are least reactive at optimum temperature. If we talk about enzyme, we already discussed these are most reactive at optimum temperature. And if these are most reactive at optimum temperature, so definitely this statement is the wrong statement. Further, we have the next statement that the optimum pH range of enzyme catalytic activity is 7 to 10. Students, this is the wrong statement because the optimum range of pH, optimum pH range for enzymes is 5 to 7. So simply this is the wrong statement. Now third option we have, enzymes are simple nitrogenous compounds having low molecular mass. It means if we talk about enzymes, these are the compounds with high molecular mass because these are proteins basically. So this option is also wrong statement. Now fourth option contains the statement enzymes form colloidal solution in water. Yes, enzymes when dissolved in water, they definitely form colloidal solution. So enzymes in water forms the colloidal solution. And on that basis, which option is the correct option? Definitely the correct option is the option 4. So let me mark here. This is our correct answer. Now let's move on to the next question. Question number 52. The incorrect statement regarding defects in crystalline solid is. We have the defect Schottky and the Frankel here, and we just have to check whether the statement is correct or incorrect. Let's see the first one. Schottky defect decreases the density of ionic solid. Basically, in case of Schottky defect, we are talking about Schottky defect, and in this case of defect, there is the removal of equal number of cation and the anion, and that results in the decrease in density. So simply we can say in this defect there is the density decreases the density. This defect decreases the density. Now in case of Schottky defect it happens. So this statement, the first statement is the correct statement. Now second statement, Frankel defect doesn't affect the stability of ionic solid. Simply in case of Frankel defect, if we talk about, this is Frankel defect. In this defect, the cation moves to the interstitial side. So basically this is a dislocation defect. And as it occurs in this case, definitely the stability of the ion would be decreased. So simply it affects the stability. So this statement is the wrong one. Now we have the third option, that is Schottky defect increases electrical conductivity of the ionic solid. It happens in this case. So this statement is also correct. And if we talk about the fourth option, Frankel defect is a dislocation defect. We already discussed about it. It is also a correct statement. So in this manner, if you check that the incorrect statement regarding the crystalline solid is the second one. So which answer is the correct answer? That is option 2. Now after this, let's take the next question. This question number 53. Upon mixing acetone and ethanol, which of the following is not observed? Basically you are mixing the two substances here. One is ethanol and other is acetone. Just recall, this mixing results in the formation of a non-ideal solution and this non-ideal solution has the positive deviation from the ideal behavior. There is the positive deviation from the ideal behavior, and if it is so, and in that particular case, enthalpy of mixing should be positive, entropy of mixing should also be positive, as well as the volume of mixing should be increased, should be more than 0. It means that would also be positive. So what is left here? Gibbs free energy of mixing should be negative, because this process is, this mixing is a spontaneous process, and if it is spontaneous, then definitely delta G should be less than 0, and we are talking about delta G for mixing. So which would not be observed here? Option 3 would not be observed. So the answer for this question is option 3. Now after this, let's move on to the next question. Now let's see the question number 54. Which of the following change will increase the vapor pressure of 1 molar aqueous Ki solution? So basically in this case we have to just check that in which case there is the increase in vapor pressure of 1 molar aqueous Ki solution. So we have the different options given here. Adding HgI2, adding 1 molar aqueous Ki, adding iodine, or adding NaI or the sodium iodide to this molar aqueous Ki solution. Simply one thing you should always remember, then whenever you are forming the complex, there is always the decrease in the number of particles and the increase in the vapor pressure. That you can understand with the help of the representation. We have the Ki when you add HgI2 to it. And in that case, there is the formation of a complex compound, that is K2HgI4. This is the complex that would be formed. Let me balance this. Now, in this case, if I check this Ki, there would be the 4 particles. Why 4 particles? Because there are 2 ions of potassium and 2 ions of iodine in the aqueous solution. So due to the potassium ions and the iodide ion, 4 particles were there. But if we look at this solution, if aqueous solution of this complex is taken, in that case there would be 2 potassium ions and 1 complex anion. This is the complex formed there. And in that case, how many particles you can clearly see here? There are 3 particles. It means the number of particles are decreased. So definitely the vapor pressure would be increased. और जब vapor pressure बढ़ रहा है तो हमारा correct option कौन सा होगा? Let's check. Adding HgI2. What about other options? Adding 1 molar aqueous Ki, there is no change in the number of particles. Similarly, if you add iodine, there is not the formation of complex. So this is not the correct answer. And the 4th option, adding NaI, that can also not be the correct option, because in that case there is no formation of complex, no change in the number of particles. So which option is correct? The answer that we can mark here is the option 1. Let me mark here. Now after this, let's move on to the next question. Question number 55. In pure water at 298 Kelvin, the electrode potential of hydrogen electrode will be given. The pressure of hydrogen, that is 10 raised to the power minus 14 atmosphere. So in this question, first we have to consider the reaction that is taking place at electrode is the reduction, and there is the formation of hydrogen gas. Now we know that the reduction potential of this electrode is equal to E standard minus 0.0591 upon N log of the concentration of product upon reactant. We have this Nernst equation here. With the help of this, we can easily find out the electrode potential there. Now we have the pure water, and we know that in pure water the value of H plus ion concentration is equals to 10 raised to the power minus 7 mole per liter. Now if we have this value, we have the pressure of hydrogen also, that is 10 raised to the power minus 14 atmosphere. It's given in the question, as well as we already have the value of E naught for the hydrogen electrode, that is 0 volt. If we have all these values, we can easily place here that ERP, E standard is equals to 0 minus 0.0591 upon the number of electrons are 2 log The product is hydrogen gas here, so I'm writing here 10 raised to the power minus 14, and the reactant is the hydrogen ion square we have to take here, and ultimately if we check the final answer we will get 0.0 volt, and if it is the answer, the option 1 is the correct answer. I'll write here the correct answer, that is option 1. Now let's move on to the next question.